Hello, welcome back to Cinderella Math. Today I'll be doing a practice college placement test. It is for a particular college, but honestly, they're all pretty similar. Of course, refer to your particular college or university for their particular test. If there's a PDF and you can send it to me, I'll do your college as well. But for this one, again, they're all pretty similar. So if you are college bound, if you're a senior going into college next year, or you're incoming college freshman and looking for just a practice test, that's what I've got for you today. I did go ahead and pull up Desmos. I don't really know if that's allowed. Probably some colleges will let you use a calculator and some won't. So again, kind of defer to your particular college, but I pulled it up. I'm not sure if I'll need it or not, but I pulled it up anyway, just in case. All right, we're going to go ahead and jump in, grab some scratch paper, and work along with me. All right. So again, most colleges, yes, this is for a specific one, but most have a placement test for math. And yeah, let's just go ahead and jump right in. Let me grab some scratch paper. Number one, what is the equation of the line that goes through the points 3, 5, and -1? Oh, mine's blocked here. -1, comma 2. Write it in slope-intercept form. All right. Okay, so remember slope-intercept form. This is what I call Cinderella. So if you haven't seen my very first video on like why this channel is named Cinderella Math, please feel free and go back and watch that. Slope-intercept form is y equals mx plus b, where of course m stands for slope and b is going to be our y-intercept. So that's going to be our final form for this. They've given us 2 points. From those points, we can find the slope. So slope is m. It's the second y minus the first y, second x minus the first x. So this is first x, first y, second x, second y. So you do this one minus this one. So it'll be 2 minus 5, and then -1 minus 3. Work out that arithmetic. So that's -3, -4, negatives cancel, and our slope is 3/4. So if it just said find the slope, you'd be good to go. But they want the entire equation. So coming back over to our Cinderella red equation, we have y equals 3/4 x plus b. And now pick either point. I'm going to pick the first one since they're both positive, so I just kind of like that better. This is x, this is y. So I'm going to do 5 equals 3/4 times 3 plus b. Now, if you're allowed a calculator, you could go ahead and whip that through a fraction calculator. I'm going to assume for a second that you're not. So that's 3/4 times 3, put in invisible 1, and that would be 9/4. Okay, so this is 5 equals 9/4 plus b. Well, we want to solve for b. So 5, we're going to subtract 9/4. Okay, again, if you're allowed a calculator, just put that through. You would just type in 5 minus 9/4 and be done. I'm going to assume you're not allowed a calculator. So I'm going to say 5 over 1. I'm going to times by 4 to get a common denominator. So that's going to be 20/4 minus 9/4. So that's 11/4 is b. So we've got the m, the slope, and we've got the b, the y-intercept. Final answer. Y equals 3/4 x, and then the b was positive 11/4. Answer. I would not go decimal. I would leave it in fraction form. Okay, give me a second. I'll check that. Make sure I didn't slip any of my fractions. That looks good. Yep, that looks fine. Answer. Number 2, solve the polynomial equation, blah, 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 blah. Okay, we want this thing set to 0 before we can solve. Find the highest degree, and by that we mean the highest exponent, so this guy. He's your boss. and you want him to be positive, which he is, because that's got an invisible 1, and that's a positive 1. So that means you don't want to move him. You want to move everything on the other side to the boss. Okay, so let's do that. So that's going to be subtract 3x squared, cancel, cancel, and put him with his friend. There's a 1 there. That's going to be add x, cancel, cancel. And then that's going to be add 1, cancel. Oh, that one cancels. Yay, okay. So that gives us 1x cubed. Do this arithmetic, that would be negative 4x squared. 2x, this canceled, and this is gone, 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 so that's 0. You don't really need the 1. There we go. Okay, that's better. Everything's on the one side, and we've got this set to 0. Now we want to factor this, if possible, and I do see on this black equation, I see a greatest common factor. He has 3x, he has 2, he has 1. So they all share 1x. So pull that out. That would leave 2, 1, and there we go. Okay, so you always want to check for a GCF. And now I would try to factor this remaining trinomial. So there are many different ways to factor. I use something for trinomials. I use something called the magic X. There's a 1 here. You do the first times the last, and then the middle. Multiply here, add here. Well, what multiplies to 2? 2 times 1, but that won't add right. What about make them both negative? That still multiplies to 2, but it doesn't add right. So this thing does not factor. We tried, and it just didn't work. So you have a couple options. I think the easiest thing to do would be to do the quadratic formula. Probably memorize this somewhere in high school, in Algebra 1 or Algebra 2. It's negative b plus or minus big square root b squared minus 4ac all over 2a. So there's a is 1, there's b is negative 4, and c is 2. We're ignoring this guy for now. He'll come back into the picture in a second, but that x that we pulled out as the GCF, just leave it. All right, going into quadratic formula, I'll be using a red pen. So our b is negative, but this says negative. So this is really negative 4, better known as 4 plus or minus big root. B is negative 4, so negative 4 squared minus 4 times A times C all over 2A. 2 times 1 is just 2. Okay. And then again, if you're allowed a calculator, you could just throw that through. But I don't know if you are. So I'll do it by hand. So this is 4 plus or minus root negative 4 squared. So negative 4 times negative 4, that's 16 minus 4 times 1 times 2. So that would be 8. But then 16 minus 8 is this. There we go. Now, technically that's the answer, but it's not simplified. So let's bring off to the side. I'm going to be in a blue pen to the left side of the screen. I'm bringing square root 8. Oops, my pen didn't change, sorry. Square root 8, and let's see if that simplifies. Well, 8 is 4 times 2, and 4 is 2 times 2. Partner, because that's how I like to do my square roots. There are other methods. So this one pops out, and this lonely guy is going to be back in, and you'll only look at the primes. So now we have 4 plus or minus a 2 on the outside, a 2 on the inside, and a 2 on the bottom. Again, technically that's the answer, but it's not simplified all the way. I'm in green pen now. We can divide by 2, which will cancel, divide by 2, which will cancel. And you never mess with the one in the root. So 4 divide 2, this would leave 2 plus or minus, he's canceled. So it's 2 plus or minus root 2. Right? And then you still have this x on the outside. Well, this equals 0. So set x equal to 0, which is just 0. There are 3 answers. You can put it in squiggly brackets if you like. So final answer is 0, comma, 2 plus or minus root 2. Okay. That one's a mess. It's a doable mess, but it's a mess. Alrighty, number 3, perform the indicated operation and reduce completely. So that looks like it is rational expression and we're adding. So we cannot add until we have a common denominator. So that guy and that guy. But first, wait, on the left-hand side, oops, sorry, right here, I see a GCF. We could pull out a 2, which would leave x plus 1. Let's do that. And the other denominator, he's fine. There's no GCF. Okay, now we're getting a common denominator. So this side needs a 2, and he needs an x plus 1. And you got to be fair and do it to the top. And the other side is missing an x plus 5. And you got to be fair and do it to the top. Okay, so now on the top, you have this with this. So you have x plus 5, another x plus 5, keep the addition, and then we have 2, and then this and this. X plus 1, x plus 1. All over, the common denominator is the 2 with an x plus 5 with an x plus 1. Technically, again, that's kind of answer, but not, because it does say reduce completely. If that wasn't there, we could probably get away with that one. But let's keep going. All right, let's FOIL this out. So foiling this would be x squared plus 5x plus 5x plus 25, plus leave the 2 and FOIL this one out. That'd be x squared plus 1x plus 1x plus 1. Okay, I'm going to ignore the bottom for a second. This would go together and be x squared plus 10x plus 25. These would go together and be x squared plus 2x plus 1. And then we're going to distribute the 2. So the first part's fine. And now we have 2x squared, 4x, 2. Combining like terms here, there's a 1. So that's now 3x squared. 10 plus 4 gives us 14x. 25 plus 2 gives us 27. And then the bottom is the same. We just ignored the bottom for a little bit. I'm thinking that's answer. But let's see if the top factors, just for kicks and giggles. So I use that magic X. You do first times the last, that's 81. And the middle number is 14. So we want to multiply here, add here. Okay, what gives us 81? Well, 1 times 81, that won't add right. 3 times 27, that won't add right. And 9 times 9, that won't add right. So I don't think this factors. I think this is answer. Usually we do not FOIL the bottom. You could, but usually we don't. And I don't have the answer key on this, so I would just leave it here. But if you wanted to FOIL out the bottom, you could. Just typically we don't. Okay. Number 4, find the domain of the function. Well, it's under a square root, and square roots can only intake positives. So this stuff under here needs to be positive. So 2x squared plus 6x plus 4 has to be bigger or equal. It can equal 0. All right, so let's pull out the 2. I see a GCF. See how they're all even? Let's pull that out. So that would just leave 1x squared, 3x, and 2. All right, well, we can divide 2. Get off. 0 divide anything is still 0. Okay, let's see if this one factors. I'm going to make my magic X. First times the last would give us 2, middle number's 3. We want to multiply here, add here. 2 times 1 and 2 plus 1. Yep, that works. So this would be x plus 2, x plus 1. If you factor differently than me, that's fine. Greater than or equal to 0. Okay, now set each one of those parentheses equal to 0. So this would come out as being -2, and this would be -1. If it was just straight up equal 0, that would be your answer. But since it's not, we're going to have to test those. And you're going to make a number line and put those on. So -2, -1. Test your favorite number in each section. So here I'm going to test -10 because it's smaller than -2, and you're going to test it into the purple step. So that would be -10 plus 2, -10 plus 1. So that would be -8, -9. So that would be 72. Is that bigger or equal than 0? Yes. So put a check right there. That worked. And then scratch this off because I could have picked any number that's smaller than -2. Okay, let's pick a number that's in between there. So I'm going to pick -1.5. Yes, that's -3/2. All right, put that into the purple step. So that's going to be -1.5 or -3/2 plus 2. Okay, so that would be positive. And then -1.5 plus 1. Oops, if I could write correctly, that'd be good. -1.5 plus 1. That's going to be negative. And a positive times negative is negative. Is a negative bigger or equal than 0? No. So put a no here. And scribble this out because we could have picked any number in between. Okay, pick your favorite number bigger than -1. So I'm going to pick 0 and put that into the purple step. 0 plus 2, well, that's positive. 0 plus 1, that's positive. A positive times a positive is a positive. Is a positive bigger or equal than 0? Yes. So our final answer is where we have the checks. So the domain of this function, so the pink goes down forever because we could have picked anything smaller. So it goes -infinity until we hit -2, and you will do a hard bracket because of we had equal. It was greater or equal. And the blue check, do the weird U symbol. That's called union. And then the blue check starts here and we go bigger because we could have picked anything bigger. Hard bracket because we had the equal. Start at -1 forever. So basically we just couldn't do the where I have no. We couldn't do in the middle there. Everything else should be okay. All right, that's the domain. If you can use Desmos or a graphing calculator on that one, it becomes a lot easier. Let me go to, again, I don't know if you can, but let me slowly bring Desmos. So you would just type exactly whatever that function was. Let me make sure I got that right. No, there. So see, it starts on -2 and goes left. So this left side of it would be this, -infinity to -2 solid, and the other side starts at -1 and goes right. So -1 to infinity. So if you can use a graphing calculator, that one becomes a lot easier, but it is doable by hand. That was 4. 5. A rectangle has an area of 8 square feet and a perimeter of 12. What are the length and width? Okay, let's draw it. So just make any random old rectangle here. Whoops, that's not a rectangle. There we go. So we know it has a length and a width, and we know the area is 8. Okay, we should know the area formula for a rectangle is length times width. So length times width is 8. And then they also tell us the perimeter. Well, if the bottom is the length, then the top is the same. If the side is the width, then the other side is the same. And the perimeter is adding up all the sides. So that would be length plus width is 12. These can go together and be 2 length. These can go together and be 2 width is 12. Okay, now you could probably honestly just guess because these numbers are so low, you could probably just guess and get this right. But I'll do it like the formal way in case the numbers aren't as pretty. Um, it's doable. You want to take this one most likely and solve for either L or W. I will solve for W. So I'm going to divide L, get off, divide L. So the width is 8 divide L. And I'm going to put that in for this width. So we have 2L plus 2, 8 divide L equals 12. So we have 2L plus, there's a 1, that would be 16 divide L equals 12. Okay, well, I don't like that L in the bottom. So we're going to times this whole entire equation by L. Distribute, distribute, distribute. That would be 2L squared plus 16L over L equals 12L. This would cancel. I'm going to come to the far left in orange. We have 2L squared plus 16 equals 12L. Let's move this over and it would go in the middle. So I'm going to minus 12L, cancel, and get 0. And then this would be 2L squared minus 12L plus 16. Factor, I see a GCF of 2, which would leave us L squared minus 6L plus 8. Magic X, there's a 1. You do 1 times 8, so that's 8 and negative 6. We want to multiply here, add here. So what if you had 4 and 2, but make them both negative? Because negative times negative is positive. So I'm running out of room. Right up here. So we would have 2. L minus 4. L minus 2. And this equals 0. Set everything equal to 0. 2 equals 0. No, it doesn't. Set this equal to 0. Length equals 4. Set this equal to 0. Length equals 2. Now, we can't have them both, but it's fine. We can figure it out from there. Right? Alrighty. So, let's come back to I'm going to kind of erase a couple things here. We had in the black pen, the width was 8 divide length. I'm going to just pick one of these answers. It doesn't actually matter which one. I'm going to pick 4. So if the length is 4, the width is 8 divide 4, which is 2. Width is 2. Let's make sure that works with the problem. So the area is length times width. So 4 times 2, is that 8? Yes, it is. And let's see if the perimeter works. The perimeter is 2 length plus 2 width. So 2 times 4 plus 2 times 2. So that's 8 plus 4 is 12. And yes, that's what it was supposed to be. So the length is 4 feet and the width is 2 feet. They could be switched and it would still work. So if you have length of 2, width of 4, that's fine. And yes, we probably could have just guessed that and gotten it right, but that's the like formal way to do it. Okay. I'm coming to number 6. Factor the expression. Oof. All right. That is tricky with all those exponentials. So this one we have x to the 5 halves, x to the 3 halves, x to the half. So they share in common x to the half. And now take that out. So you would still have 3, and then you subtract out what we took out. So you're going to do 5 halves minus a half. So that's 4 halves, which is 2. So that'll be x squared. Plus, you still have 3, and then subtract out. So that'll be 3 halves minus a half. So that'll be 2 halves, which is 1. So that'll be x to the first, or just x. And then this one will just be 2, because you took out the x half. All right, let's see if it factors further. So looking at this trinomial, I'd make my magic x. That would be 6 and 3. What multiplies here adds here. Well, 6 times 1, no, that doesn't add right. 3 times 2, no, that doesn't add right. I don't think that factors. Answer. I think that's the best you can do, is just pull out that x to the half. Coming to 7. If sine of theta is -3/4 and theta is in quadrant 4, what is cos theta? Okay. So remind me of the quadrants here. 1, 2, 3, 4. And we have a saying, all students take calculus. So because we're in quadrant 4 and we're dealing with cosine, see how the C is right there? The answer is going to be positive. So we do know that. So if this was multiple choice and some of them were negative, you'd get rid of those. So we know the answer is going to be positive. Okay, so let's draw our triangle down there in quadrant 4. So start at the origin, straight, straight, kick. So your right angle's here and your theta is here. I'm going to white out the 4 so it's not in the way, and the C. Okay. All right, sine. Think of your SOHCAHTOA. Sine is OH. So OH. So the opposite from theta is 3. And because we're going down, we're going to make that -3. And the hypotenuse is 4. So we need to figure out what this one is. I'm going to call it X. Pythagorean theorem, because it's a right triangle. Leg square plus leg square equals hypotenuse square. Go ahead and just work that out. So x squared is 7. So x is √7. Leave it like that. Don't push it in the calculator. It'll be nasty. Okay? And now we're going to get the cosine. So again, remembering SOHCAHTOA, cosine is ka. We need the adjacent and the hypotenuse. So cosine of this angle. The adjacent is the flat leg touching the theta. So that's the √7. And the hypotenuse is across from the 90, which is 4. Not negative, just 4. Answer. Okay, that's just some basic trigonometry there. Also, some trigonometry. Let theta be an angle which of the following expressions is not equal to 1. If you have a really strong trig background, you might just know this. Okay, but I'm going to pretend that you don't have a really strong trig background. So just make a triangle, and it does, of course, need to be a right triangle. That, well, doesn't have to be, but do it anyway. Put your theta, and then I'm going to just make up some things. I'm going to say across from theta, so the opposite, I'm going to say A. The adjacent, I'm going to say B. And the hypotenuse, I'm going to say C. Okay? And now let's jot down the 6 trig functions of this theta. So SOHCAHTOA, the sine of this theta is so opposite, hypotenuse. The flip, the reciprocal of sine is known as cosecant. So just flip that. Cosine would be adjacent hypotenuse. The flip of cosine, the reciprocal of cosine is secant. And then you just flip that. And finally, tangent is opposite over adjacent. And the flip, the reciprocal of that is cotangent. Okay, so there's all the things. Yes, we could have faked it with numbers. If that makes you more comfortable, put like 1, 2, 3 on there and you can fake it that way. Okay, we want to see which one's not equal to 1. So let's look at A. They want us to take the cosine square, so that would be B over C squared plus the sine squared. So that would be A over C squared. Okay, so that would be B squared over C squared plus A squared over C squared. That has a common denominator. So that would be, whoops, B squared plus A squared over C squared. But this is a right triangle. Pythagorean theorem. A square plus B square is C square. So this right here, this is C square. So this is C square over C square, which is 1. So this one equals 1, and we're looking for which one doesn't. So A is out. Okay, I'm going to have to erase, so pause me if you're still copying anything down. Now I'm going to check on B. So B says do the tangent divide the sine. Okay. So tangent is A over B. Divide the sine, which is A over C. So that's division of fractions. We're going to keep, change, flip. Keep, change, flip. Cross cancel. C over B. That's not 1. I think that's the answer. That is not 1. Let's check though. Pause me if you need to. I'm going on to C. C says tangent times cosine over sine. Okay, tangent times cosine over sine. Okay, on the top, the b's would cross cancel, and we get A over C divide A over C. Keep, change, flip. A over C times C over A. Cross cancel. Nothing's left but an invisible 1. That is 1. And now let's check D, as in dog. Cosecant, okay, times tan, okay, times cosine. Cross cancels. We're left with the C over C, which cancels itself as 1. So the only one that's not 1 is B as in boy there. Okay, there was other ways to do that, but to me that was the easiest. Which of the following statements are true? All right. Again, if you're really strong in your algebra, you can probably just do this one. Like just know it. It is C. Or wait, is it C or? No, it's B. My bad. And you can just kind of look at it and know. But if you're not super great at your algebra or this just looks crazy, it's easy enough to work out. So looking at A, let's do A plus B squared. You know something squared is times by itself. So this is A plus B times A plus B. And then we're going to FOIL that. A times A is A squared. A times B is AB. Another AB and B squared. There's a 1 here, there's a 1 here. These go together. That makes 2 AB. Okay, so that is not what A says. So A is not true. That is what B says. B is the winner. That is the foiling, the correct foiling. C is just dumb. Okay, it's B as in boy there. Simplify the expression and write using. Okay, so number 10, you need to know your properties of logs. This is a natural log, but it's fine. Same thing. So when you see a plus, we really multiply. So you're going to do this one, multiply this one. And when you see a minus, we're going to divide. So this is going to be natural log of 4x squared times xy divide 2y. Okay, that's kind of step 1, and now we just need to simplify. So this is now natural log. That would be 4x3, right? Because there's a 1 there. Y over 2y. Okay, that's still not simplified all the way. The y's cancel, and 4 divided 2 would just be 2x cubed. Answer. That's a lot better than the original problem. So again, when you see a plus, you're going to multiply. That's just a property of logs. And when you see a minus, you're going to divide. Okay, 11. Simplify the expression. Okay, so another log. All right, now the rules, though, only apply if they have the same bases. So look, this is all messed up here. This is log base 2, log base 3, log base 4, log base 5. So we can't do those rules. We're going to do each one of these separately. Let's just do log 2, 16. Let's say this equals x. I make a little heart. Put your pencil here, heart, heart. This is 2 to what power is 16? You might just know that in your head. If not, you could use a calculator and guess around. If you're not allowed a calculator, well, 16 is what? 8 times 2, but that's 4 times 2, but that's 2 times 2. So 1, 2, 3, 4. 2 to the 4th is 16. So this answer here is 4 minus. Okay, keep going. Now let's just look at the second one. See this 2? Let's just drop it down. And now let's just do this. So we have log base 3, 3 cubed is what? Heart. So we have 3 to the what is 3, 3. So this x is 3. So that answer there is just 3. Keep the plus, keep the 3, and let's work on this one. So we have log little 4 of 2 is what? Heart. 4 to what power is 2? Well, if you think, you're like, wait, square root of 4 is 2, yes, and a square root is a half power. So 4 to the half is 2. So that's just going to be a half plus. Last one, there's nothing to drop, so we're just working this. Log base 5 of 25 is what? Heart. 5 to what power is 25? And that would be 2. There we go. Now let's just work that out. So we have 4 minus 6 plus 3 halves plus 2. 4 minus 6, that'd be negative 2 plus 3 halves plus 2. Negative 2 plus 2 cancels, and we're left with 3 halves, or 1.5. That's a bit of a pain, not gonna lie. If you're allowed a calculator where you can input bases, so if you are allowed Desmos, and I know some fancy calculators do this, that was what? Log, and then to get a base here, base 2 of 16 plus or minus 2 log 3 of 3, log 3. Oops. Okay. Plus 3 log 4, 2, 3. Okay, I'm just checking this one and showing you how you could do it if you're allowed a good calculator. And 1.5, which is 3 halves. So yep, it was right. All right, coming to 12. A bottle of soda at room temperature is placed in the fridge to cool after T minutes. How long does it take to reach a temperature of 55 degrees? Okay, so that's the temperature we want the soda to be. So that is our temperature. So 55 is going to go in for temperature. So we have 55 equals 44 plus 28 e to the negative 0.17 t. And we're solving for t. That's the time it takes. How long does it take to cool down our soda? Solve. Okay, we're going to minus 44. So that's 11 equals 28 e to the negative 0.17 t. Divide the 28. So 11/28 is e to the negative 0.17 t. And now the opposite of e is natural log. So ln cancel ln. Coming up here. So natural log 11/28 equals negative 0.17 t. And then just divide. Negative 0.17, negative 0.17. If you are not allowed a calculator, this is your answer. You can't do natural logs in your head. So you'd have to, at this point, if you are allowed a calculator, just plug that in. natural log 11/28 divide negative 0.17. And we get 5.49. I'm going to round that. I'm going to say 5.5. Okay, so T is 5.5. And what were we measuring in? Minutes, probably, after T minutes. So it's going to take 5.5 minutes for your soda to cool down to 55 degrees. All right, I'm on 13. Don't know why that's highlighted. Get off of there. Anyway, suppose, okay. So this is just working with functions. This is our function. Over here, it says we need f of a plus h and f of a. So we're going to do f of a plus h. So everywhere we see x, put in a plus h. So this would be a plus h squared minus a plus h. Well, let's square that out. So we need to FOIL it with itself. Okay, so that's going to be a squared ah ah h squared, and then distribute this minus. Okay, combine like terms, which I think is just these two right here. There's a 1, there's a 1. So this would be a squared 2ah, and then just drop everything. Okay. That is f of a plus h, the blue. And now look back to the original question. We also just need f of a. So now let's do f of a. So wherever you see x, put a. So that would be a squared minus a. Okay, that one's a lot easier. Now, the actual question says to do f of a plus h, so the blue answer, minus the green answer. And I'm ignoring the bottom for a second. So I'm in the red. This is all just going to copy down, distribute this negative. Does anything cancel there off the red one? A squared minus a squared and negative a plus a. So we are left with 2ah plus h squared minus h, and this whole time it's been over h, so over h. What factors out of the top? They all share an h, so pull that out. That would leave 2a, 1h, and minus 1 all over h. This would cancel, and we get 2a plus h minus 1. Answer. That is called, oh gosh, that's just slipped my mind. It's calculus. It's baby calculus. There is a better way to do that, I promise, but for now, there you go. Quotient, like the difference quotient or something. I forget the name of it, but it'll come to me when I'm done with this video. Right, simplify. Okay, so this is exponent rules number 14. Okay. So just looking at the inside, 2, 4, a negative 3, b 4. Okay, I'm ignoring the outside. 2/4, you can reduce that to a half. And then see how this one's negative? That means he comes to the bottom. Okay, that would be the answer if it was just the parentheses. But then this whole thing is raised to the negative 2. Okay, but that's naughty, right? It's naughty to have a negative. So we're going to send this whole thing to the bottom. So we're going to make a fraction, send this entire thing to the bottom, and put a 1 on top. Okay, so that's now. Square this one. 1 squared, so that's 1. 2 squared, that's 4. And then the rule for exponents is you multiply. So that would be A6, B8. But then I don't like this double fraction, so we're going to keep, change, flip. So we're going to keep the 1. change to times, and flip. Ones are gone. Final answer, 4a to the 6th, b to the 8th. Okay, I'm going to do that another way. That might have been the harder way. You could just go straight from the beginning right here. 2 to the negative 2. Multiply, so that would be a to the 6th, because negative times negative. That would be 4 to the negative 2. Multiply, that would be b to the negative 8. And now just fix that. Well, this one's negative, so it's going to come down. These two are negative, so they need to go up. So on the top, we have a6, b8, 4 squared. And on the bottom, you would just have 2 squared. So that's 16 a6 b8 over 4. But 16 divided 4 is 4. So final answer, 4a6 b8. Okay, they both got us to the final answer. Pick which one's ever easiest for you. They both worked. All right, I'm on 15. Simplify the expression. Write your answer in exponent form. Okay. All righty. So right here, we can go ahead and subtract, right? The rule for exponents is if you're dividing, you're really going to subtract. So we can say that's x cubed, and then we still have the stuff in the root, and then we still have y squared. Okay. Write your final answer in exponent form. Okay. So with a square root, we're looking for partners. So we have 3 x's. So this would be a partner. So this would come out. This would stay in. And we have 7 y's. 1, 2, 3, 4, 5, 6, 7. Partner, partner, partner. So this would stay in. So the top is now x cubed. This one set is coming out. 1 stayed in. And on with the y's, 1, 2, 3. So 3 sets came out. This one stayed in. And on the bottom, we still have y squared. Okay, so this is now 4 x's. And then see these y's right here? We can subtract. 3 minus 2 would give us 1 y. So cancel that and just make it 1 y. And then we still have an x and a y in the root. Technically, that's the answer, but it says exponential form, so I don't think they want any roots. So this would be x4 times y times x to the half y to the half, because a square root is the same as a half power. But when you're timesing, you really add. So that's x to the 4.5, which is 9 halves, and y to the 1.5, which is 3 halves. Answer. Okay, there's another way to do that. I'm going to write that answer to the top and make sure I'm going to show you a second way, and then you can pick what's more comfortable for you. All right, let's start that all over. Here's what we can do. So we have x to the 5th, and then this is x to the 3rd to the half, because it was in the root, y to the 7th to the half, because it was in the root, all over x squared y2. Okay, so working out the top, that's still x to the 5th. You multiply, because that's the rule, power to a power. So that would be 3 halves. Multiply, that would be 7 halves. And then the bottom's fine. On the top, we're going to add these together. That's 5 plus 3 halves. Well, 5 is 10 halves, right? 10 divided 2, that's 5, plus 3 halves. So that's x to the 13 halves, y to the 7 halves. And on the bottom, 2 is 4 halves, right? This is 4 halves, because 4 divided 2 is 2. And now the rule is when we're dividing, we subtract. 13 minus 4 would be 9 halves. 7 minus 4 would be 3 halves. Answer, same answer, different method. Okay, I don't think think I made any mistakes on here, but I could have. I don't have the answer key, but this is, in my opinion, it's pretty difficult for an entrance test. They don't expect you to get them all right. They don't, okay? Do what you can. Some of them are definitely doable, for sure, but some are quite tricky. I hope this was helpful, and I hope you're having a great day. And if you have any other placement tests you'd like me to do, put the link to the PDF down in the comments, and I will do them. Thank you, and I hope you're having a great day. Bye-bye.